in my record, we were doing hydrolysis of acyl chloride. Hydrolysis. Now look at this theme. Hydrolysis. Hydrolysis is a reaction of a substance with water. We discussed this article, we started this title, and last class we have mentioned that it is the introduction of OH group. Now, I hope you remember this reaction. Achha, do you remember what are acyl chlorides?
Yeah.
What are acyl chlorides?
It's
Are,
the COOCl group, no?
It's basically a chlorine derivative. Okay. Now, in this equation, if you see in this equation, look at this. This is an acyl chloride. This is an acyl chloride. Now, what this reaction is showing, the OH group, look what happened.
Yeah.
Can you
It
identify
attacks
what?
it.
Shabash.
It attacks it, yeah. Hydrolytic fission and then OH attacks.
And is it a type of substitution?
Yeah, nucleophilic.
It's a type of substitution. General mechanism of this nucleophilic substitution, it is called condensation, addition, elimination mechanism. So you have to give this heading.
Do I copy this?
Yes, you have to copy this heading. Condensation is a discussion was made in polymerization. It's a concept of removing water.
Yeah, copy.
Now, look at this concept. Step number 1, the nucleophile attacks the carbon, which is electropositive carbon. The nucleophile attacks the carbon, which is positive. This will eventually break the carbon-oxygen bond. Obviously, you remember the curly arrows. What is the result? The double bond between carbon-oxygen breaks. Now, the nucleophile is also sitting in the molecule, but why the molecule has become unstable? There is a negative charge. Look at this. There is a negative charge on a local side. It's a local negative charge which is giving instability. So now you have to copy these steps. These are called mechanism. This is the step one, which shows that the nucleophile is attacking the carbon. Now, let me know, Shahid, if you have copied it.
Yeah, copied.
Okay, so that's good. So can you explain this back to me, how this, because you know about these curly arrows well, the nucleophile attack. So can you explain this? Sorry. So can you explain the step one?
The electrons go to the oxygen.
Mhm.
The pi bond breaks.
Yes,
So
pi bond,
then,
uh, heterolytic fission.
yeah, then the nucleophile attacks the carbocation, and an intermediary state is made.
An intermediate is formed, and why the intermediate is unstable? The intermediate is unstable because there is a local negative charge. Step number two. Now, the instability fire back the negative charge on oxygen. Now transfers electron to the carbon. Carbon takes a golden shake hand with chlorine and kick out chlorine with the electron. So chlorine, like a bargain, like you are happily leaving the job with some benefit, chlorine take up its own electron, which is coming from oxygen, and chlorine leaves. In acyl chloride, the leaving chlorine is the main mechanism. Chlorine is always ready to leave. So chlorine is always happy to leave. So chlorine immediately leaves the system. Chlorine is now negative. It's a heterolytic fission. This is the step number two. You know, mechanism comes as they are. I mean, like a recall. So mechanism should be understood, but mechanisms actually appear like a understanding.
Okay.
So now you have to copy this step. Let me know once you have copied it. Okay, have you done it?
Yeah, copy.
Reactions of acyl chlorides with ammonia, primary amines, alcohols, and phenols. These are, again, remember this concept that acyl chlorides are derivatives of carboxylic acids. Simply, you have introduced chlorine. Speciality is that acyl chlorides are organic reagents. I mean, themselves, they are not very important, but they convert many compounds into useful organic compounds. So they are like a bridge connector. So they are important organic reagent. So some of the reactions are now there. Reactions of acyl chlorides with ammonia, primary amines, alcohols, and phenols. So now you have to give this heading. Now, can you, if you have copied it, can you recall ammonia is NH3? Amines, what were amines?
C triple N.
RNH2.
Wait, C triple N is nitriles?
C triple bond NH is basically nitriles. If you are
Okay.
talking about that molecule is, you're talking about this one, RCN, this one.
Yeah, yeah, this one. This is
Uh, this,
nitrile, yeah.
this compound is, this family is called nitriles. They're also called cyanides. Acha, amines, if you have to memorize these type of uh, series always. Now look at this. This one is RNH2. This one is RNH2. This is called amine. You know very well what are alcohols. ROH. Phenol is something new. We haven't done it, and it's not in unit 4 actually. Right now in this chapter, it comes as a reference. This is called phenol. And you know very well what is ammonia. Ammonia is NH3.
Okay.
RNH2 amine, RCONH2 amide, NH3 ammonia. Now these are very important sheets because this is actually where organic chemistry has no compromise. You have to memorize them. What is amine? What is amide? What is ammonia? So after giving the heading, you have to copy this.
Yeah. Okay.
These you have to memorize. Now look at this. What are alkyl radical? This you have know already. We have discussed it many times that if you remove one hydrogen, if you remove one hydrogen from, if you remove one hydrogen from an alkane, the remaining part, remaining species is called, the remaining species is called what? The remaining species is called alkyl radical, like CH3, like C2H5, like C3H7, etc. Now look at the reaction with ammonia. We need to discuss the character of ammonia. We need to understand very effectively. We need to understand very effectively that how ammonia behaves. In ammonia, nitrogen has a lone pair. Look at this lone pair. In ammonia, nitrogen has a lone pair, and you have studied in bonding that lone pair is responsible for many features, like you can say, lone pair is responsible for many features like shape, bending of molecular bonds. So remember this concept that in ammonia, nitrogen has a lone pair. Look at this. This is a lone pair of electron. It has a lone pair of electrons. Okay. Like this one. Now this lone pair has two contribution. Ammonia behave as a base. Ammonia also behaves as a nucleophile. Achha, now can you recall for me what is a base? According to the theory, base is an, yes, what was the theory? Base is an,
Electron donor.
yes, electron pair donor. Acha. Then what is a nucleophile? Interestingly, same definition apply for nucleophile also. Nucleophile is an electron pair donor. Nucleophile is an electron pair donor. Okay. So now quickly recall, we are starting reactions with ammonia. In ammonia, nitrogen has a lone pair. Due to the presence of donatable lone pair, ammonia is a base as well as a nucleophile. So ammonia has a double character. Ammonia can behave like a base. Ammonia can behave like a base, and ammonia can also behave like a nucleophile. Now, here is the word equation. Acyl chloride plus ammonia gives you amide plus HCl. Acyl chloride plus ammonia gives you amide plus HCl. So now you have to copy this word equation. Yes. Shahid, have you copied it?
Yeah, copy.
So now this is the word equation. Can you recall what is an amide? What is an amide?
And NH orange.
Amide is RNH or RCONH2. You have to look for it.
Sorry, NH2, not NH3. NH3 is ammonia.
It is basically R. What it is? It is basically RNH2. RCONH2. Now look at the word equation. Reaction with ammonia, RCOCl. You have to carefully see the behavior of ammonia in this game. Ammonia is providing an NH2 group and taking away the chlorine. Remember, chlorine is always happy to leave. Here, ammonia is acting as a nucleophile. Ammonia is acting as a nucleophile. To look at the complex nature here, ammonia gives out NH2 there, Cl leaves, and Cl combines with hydrogen. Interestingly, look at the second connecting reaction, this one. The HCl is
Yeah.
obtained from here, ammonia will come from here. Now, what is the speciality of this reaction? One of the product, HCl, is actually going to react with NH3, which is a very strange thing. Normally, it doesn't happen. But one of the product, which is HCl, reacts with one of the reactant, ammonia, and ammonia reacts with HCl to form a salt. Here, ammonia is acting as a ammonia is acting as a base. So I make up my concept again. Ammonia is here. It is going to kick out chlorine by breaking this bond, and NH2 will come in place of it. Whole ammonia cannot enter in any molecule because NH3 is a complete structure. Second interesting thing is HCl and NH3. They combine together to form NH4Cl. Okay. So now you have to copy this.
I copied the equation, right?
Hmm? Huh. Can you please repeat your question?
I copied the equation at the bottom as well.
Huh.
On
That is a part of reaction. That is the reason we have to keep ammonia in control because this reaction is an unwanted reaction.
Okay.
Let me know once you have copied the equation.
Yeah, done.
Hmm.
Copied it.
Now, look at the first reaction. The first reaction is an example of nucleophilic substitution. Ammonia is providing NH2. NH2 is replacing chlorine. That is a substitution reaction. Second reaction is acid-base reaction. Now, give the heading reaction with amines. And again, recall what are amines?
Amines are RLH2.
Amines are RNH2. Look at this. NH3 is ammonia, RNH2. If you introduce an R in place of a hydrogen, it is called amine. Now, contrast. In ammonia, there are 3 hydrogen with a nitrogen on with lone pair. In amine, there are 2 hydrogen with a CH3 group or any alkyl radical. Nitrogen still has a lone pair. No need to copy that. You have to absorb it. Can you now compare between ammonia and amine? Can you differentiate between ammonia and amine?
Yeah.
So what is the now? Can you recall? Can you explain that? What is the difference between ammonia and amine?
Ammonia is NH3 and amine is RNH2. That's it.
And the R group, look at the R group. The R group is actually, the R group has replaced one hydrogen. Now I put my next cons. Look at the reaction again. Again, observe the acyl chloride RCOCl. Now it is CH3NH2 nucleophile. Then look at this reaction. Look at this reaction breaks here. Chlorine. Chlorine deattaches, and look at this NH2 is coming here, NHCH3. This whole molecule fit here, but a loss of hydrogen. There are 2 hydrogen, and now there is 1 hydrogen. This 1 hydrogen combines with chlorine to form HCl. Again, the same interesting, unique reaction, which normally doesn't occur in chemistry, but here, this is a This is a basic base compound. This is an acid. They react together to form a salt. So in these reactions, there is an interesting feature that one of the product reacts with one of the reactant. Now, interestingly, the first reaction in this screen, the first reaction is nucleophilic. The first reaction is nucleophilic and the second reaction is acid base. So now you have to copy this for understanding. Yes, let me know once you complete it.
Yeah, copied.
This is a typical acid-base reaction. Now, our next title in acyl chloride, esterification. We did it earlier also. It's a recall for acyl chloride. Now, what is esterification? We have discussed it at least 2 times in our session, in our previous sessions, that esters are alkyl alkanoids. We know them very well. How alkyl alkanoids are formed? Look, the reaction alcohol plus carboxylic acid gives you ester plus water. This is our memory. Now is the entry of acyl chloride. I mean, acyl chlorides can also make esters, and they are so effective that they do not need H2SO4 as a catalyst. Uh, Acyl chlorides are themselves very active. So RCOCl with ROH alcohol. Look at again what happened. The Cl goes out and OH comes, and the R group comes in. HCl is formed. This is another route for making ester. Do you remember? We were using H2SO4 in our previous esterification here. Why H2SO4 was used? Because it was a catalyst, it was a drying agent. Now here we are not using any catalyst because RCOCl, acyl chloride, are very reactive themselves. So after giving the heading, you have to copy this. This is a reaction with acyl chlorides. So RCOCl plus R prime ROH, RCOOR plus HCl. My point to understand here is what is the difference between this esterification and the previous esterification. The fundamental difference in the previous one, we were using alcohol and carboxylic acid, and we were also engaging an acid like H2SO4. Here, no H2SO4 is needed because the reaction itself is very, very motivated. So have you copied this reaction?
Yeah, okay.
Okay. Look, now reaction with phenol. Acha, this is important to understand that what are phenols. Phenols will come later in our next unit. Phenols, like, but we have a rule that whenever you come across anything which is new, you have to make an introduction. Organic introduction is actually the functional group introduction. So you have to give a side heading, phenols. Phenols are actually aromatic alcohols. Phenols are actually aromatic alcohols. So give us side heading, phenols. Phenols are aromatic alcohols. They are aromatic means they have a benzene ring. Now let us introduce both of them. Both of them are very important for the later section. Uh, this compound is a ring compound. Look at this. It's a ring. This compound in our chemistry is called benzene, a mysterious compound with lot of reactions, applications. So benzene is actually, after alkene, is the biggest important compound family. Benzene is a very important solvent, very important but very dangerous organic compound. So you have to now copy this. Now this is benzene. This compound is called phenol.
It's the aromatic phenol. Is that what it is?
It's an aromatic alcohol.
It has a specific smell and taste, right?
It has a benzene ring, so you have to remember is phenol is a phenol is a benzene derivative. So now you have to make a memory. You have to introduce another family of organic compounds in your memory that are called phenols. Phenol is basically an alcohol group in a benzene ring. So it's a benzene with OH group. You have to copy this. Let me know once you have copied it.
Yeah, copied.
Good. Now we move forward. Reaction with phenol. We are actually discussing acyl chloride. Look at the acyl chloride now reacting with phenol. Remember this idea. This actually Cl is the main agent to leave, and the benzene ring will come in there. Benzene ring will replace chlorine from acyl chloride. After the reaction, you will get an ester. What is something different? This is an aromatic ester. What's an aromatic means? Whenever something contains the benzene ring, this is special structure with a circle inside it. So when an organic compound contains benzene ring, it is called aromatic compound. Aromatic means aroma. Aroma is a special type of unique smell. Now you have to copy this. The second line is showing the structural formula. Yes, Shahir, if you have copied me, please let me know.
Yeah, wait. Just the equation, that's it.
Okay. Yes, have you copied it?
Yeah, copy.
Now, condensation polymers. What are condensation polymers? The topic now recalls our IGCSE theory of condensation polymers. So give the heading condensation polymers. Now, can you recall, Shay, there are two types of polymerization. One is called addition polymerization, and second is called condensation polymerization. So recall this, actually better copy this and you can orally tell me what
Could
was
you
addition.
tell me what condensation was again? Addition was just you add, right?
Hmm,
Keep on adding it.
you just add them.
Yeah.
In condensation polymers, we actually connect the monomers by removing one or two molecules. So we create vacancy. We kick out someone to create a vacancy. Normally, water molecules is kicked out. Normally, water molecules are kicked out. So these are, acha, orally, look up the definition. It is basically a concept of removing molecule or particles in between the monomers. We join the monomers after removing some of the particles. We join the we connect the monomers. We connect the monomers after joining the sorry, after removing the molecule like water, we connect the monomers. Look at this bead structure, color is changing. This is called a condensation polymer. Common condensation polymers are polyamides from a dicarboxylic acid and a diamine, polyesters from a dicarboxylic acid and a diol. So in our course, there are two types of condensation polymers which are involved. Polyamides, which is coming from a dicarboxylic acid and a diamine. And what are polyesters? Actually, once you understand esterification, then the concept of polyesters can be understood easily. Polyesters are actually ester linkage between the monomers. Ester linkage between the monomers. Okay. So this chapter is nearly finished, but we will complete it inshallah in our next class. Okay. Allah Hafiz.
Okay. Allah Hafiz.